Alright, Bismillahirrahmanirrahim. My name is Ahmad Qadir Najmi. I'm from class EC1105E. Okay, today's video is about to explain how the load of a building has been transferred into the earth by via the structural members. Okay, let's have a closer look into the diagram here. So the diagram here is already been leveled with orange arrows, which is representing the load. First of all, let us take a look at the top of the building. Okay, so this is at the top of the building. So as you can see, the roof here is actually the truss structure, one of the structural members, which is the truss that protect the building from the weather uh, and the other thing that falls onto the building. So as you can see, the tiny orange arrows here represent the load here applied to the roof, such as the atmosphere pressure, some raindrops, and even falling objects that fell onto the roof. So from the roof, the load, the force, has been directly transferred into a column here. As you can see, for this structure, for this architecture, there is a column that supporting give you the direct support onto the truss. So the load from the truss has been transferred direct into the column and transferred all the way down into the foundation, and from the foundation the load will be endorsed into the earth. Okay, but okay, for an extra information, this is actually a Gothic architecture, seni bina Gothic, from the Dark Age of Europe. Therefore, this is most likely this kind of architecture most likely being used in castles and churches. So why do they need to use this kind of architecture? This is because the building back then has to be super huge and super tall, and they are all 100% made of heavy materials such as stone bricks, sandstones, and such. So when they have heavy loads that really high, they need an extra support, like these kind of columns, like right here. Although these have some column features, they do not call it as a column, but instead they call it as a buttresses. With some voids here that you may have seen, they that have been replaced with some arch here. They call this as flying buttresses, as they have this wing look. Okay, so from back to the top, from the truss, with heavy loads from the truss and heavy loads from the taller side of the building has been transferred all the way to the beam here. It's kind of weird to see this beam is not 90 degrees, but it still have this beam function, that is to maintain tension and some compression on the top. This is because the load from the building has been transferred vertically to the side of the building and transferred into the buttresses. The load in the buttresses then will be transferred into the foundation and being spreaded into the earth. Okay. Now, when we look at this kind of architecture, we will realize that there is not enough structural member. I mean, we don't have slabs here. So how can we how can we um, how can we understand this better, right? So I will give you the next example that will give a better picture, literally. So from the Europe, we're going to see this Far East architecture. Now this picture is quite complex for us to understand. So I got a simpler one. So as you can see here, from the top of the from the top uh, of the building. Wait, let me just please wait for a moment. All right. Oop. Okay. From the top, from the top of the building here, that has may contain lots of load, will be directly transferred to the main column here. But I will explain it better, more details. All right. Alright, as you can see here, there are actually several separated pillars or several separated columns inside of the building. Now, as you can see, there's a different colors here that has been labeled because they are supporting different levels, the different levels lah. For example, if you can see the blue star here representing the blue star, the blue pillars here only supporting from the 5th floor into the 4th floor, and then beneath that pillars is another separated pillars that supporting from 2nd floor to the 3rd floor, just like this one. All right, so let us have a little bit understanding here. The crown of the castle here, this is basically a Japanese castle lah. The crown of the castle here would be very heavy, but the structure is 100% made of timber, which is not a heavy duty material, just like the Gothic architecture just now. So how do they be able to build this? So from the top here, yeah, as you can see, so the load from the truss has been applied directly into the blue column, and then from the blue column, it won't go straight into the foundation just like the Gothic. It instead it been separate. It's been spread out. Wait, let me take my red pen back. Okay, so this red line here representing a slab. So I'm gonna take orange now. So from the column here, the load will be separated out like that, changing a vertical force into a horizontal force. And then from there, the 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 load on the slab will be transferred into another pillars, and also pillars beneath the main pillars before, and the process repeat until they found the foundation. Alright, that's how it's worked with slab. But there's a little bit different here. As you can see, I'm gonna use this green pen now. So this is a truss system, but this is a truss structure, yes, the roof, but this is a roof too, and these are the roof of some roof too, which mean there are trusses in here. So there are different trusses that been supported by different pillars but being attached with same slabs. That's how the engineering works. Alright, so maybe we don't have still don't have the clear picture here. So I'm going to look at more simpler architecture, more simpler model. So this is a simpler one, but the label here, we can't really read these labels because not all of us could read Japanese, so I have the simpler version. Okay, so from this simpler version, as we can see, there's a very clear detail of truss, and then from the truss, wait, let me take my so back to that. Okay, so these are some trusses here, as you can see. So from the truss, the load will transfer to this beam. Yeah, as you can see, there's a beam. So the vertical load from the truss will be transferred into a horizontal force to spread the force lah. But then from the beam, I'm gonna take yellow here. The load will be transferred to the column. This is a column. This is here the column. This is the column. This column. As you can see, there are so many columns lah. So the column will took over the load from the beam, from changing from the horizontal force into a vertical force. Okay, and then from the pillars here into the ground, and then the green one represent the foundation. And then from the foundation, the load will be separated evenly into the earth. So the blue one here is representing the slab. There's a slab for shielding there, and slab for the floor that will prevent spaces and for the consumer to store anything or just simply be in this space. Alright, so from the space here, let's say this door or any furniture in the house have some of load. So from the from there, the load will be transferred in onto the slab and then directly onto the beam. There's a tiny beams here if you could see it properly, and then from the beam, the load will be transferred into the column and then direct to the foundation, just like before. So that's the simpler version of it. So maybe we could ask, because of this image is not 90 degrees straight, where we don't have this pandangan hadapan right there, the 90 degrees view here, so it might be seen a little bit complex here. So let's see if we could get a 2D flat image. So I have standby here the Parthenon. The Parthenon here is basically a temple for a male deity of ancient Greek. So that's why it have this muscular features of the building. As you can see, it's kind of short and wide. Okay, so choose red back. Okay, this triangle, this big triangle is the truss. Sampai sini lah. Okay, and then there's a little bit trigon here. You can see the tree line there supporting on top of the very long lintel, that act as a beam, very long beam. And then basically from the truss, the load, wait, let me portray the load. The purple arrow here representing the load. Then the load has been applied onto the truss, and then the load from the truss has been applied onto the trigon there. And then the trigon there is kind of acting like a slab because there's a space inside that. So we could consider it as a slab lah. Okay, and then from that slab, the the load has been applied into the yellow line there, the yellow label there, the lintel that act as a beam, and then from there, from the beam, the load has been applied directly onto these columns there, and then directly onto the foundation, and then the load will be spread around that. Okay, so this is the most simple version lah, from the complex version until this is the most simplest version. Okay, yes. But this is like I said, have this muscular features because this temple is worshipping the male deities, Greek deity. Like this one here is for the Athena, the female deity, so that's why it seems a little bit feminist. As you can see, it's taller and it's not white. Have this feminist feature lah, but have the same characteristic. The load from the truss applied onto the lintel, onto the beam, and then directly onto the column, and then finally onto the foundation, and then into the earth. Alright. Okay, this is the last slide of today's video. Okay, so why do I feel like I need to show you this one is because the uniqueness of this structure. Okay, as you can see here, there's a very huge column in the middle of this building. Now, this building has been categorized as a pagoda. Okay, so this column has its own name. It's called Shinbashira. Shinbashira here, this huge column here, is not on one piece of column. Like it's not just one timber from the foundation straight up to the truss. No, it's several pillars that been attached together and have these flexible features on every level. Let me grab my pen here. Alright, so I'm going to separate the pagodas into the levels so we can have the better picture. Okay, so the red lines are representing the slabs and beams. Okay, the slabs and beams because the slabs and beams, the slabs are not very thick. They are just made of some plank, some timbers, so it's not very thick as it made of bricks or whatnot. Okay, concrete or whatnot. Okay, so these okay, so each floors here have its own truss, just like the previous Japanese castle. So I'm going to label the truss as orange. So these are the truss, and then from the truss, because the crown of the pagoda has the biggest truss, so I have to shade it out lah. Okay, and then some here, some there, some there, some there. Okay, so from the truss, the load has been transferred by beams. So as you can see, there's a beams here, very clear, the beams there. Okay, and then from the beams, what do? They have their own columns from the beams. As you can see, these columns there that carry out the load from the top onto the ground, and everything should be okay. But hang on, what you might be thinking, so what is this big fella doing in the middle? So this Shinbashira here is not acting as a compressed beam, as a compressed column. This is the most one of the unique column in the world lah, because most common columns has been used by your apply a vertical load, like let me use purple apa to label as the load. So when we have load, it should be travel vertically downwards the beam, right? But no, in this uh, in this in this case, the vertical load has been transferred in this green line here. So what does this blue pillar does? Okay, what does the what is this blue pillar does is tension. As you can see, the beam here is attached to the middle pillar here, middle column here, as a tension, because this Shinbashira here, the blue one, is acting like a spine, a backbone for this tall structure. Because in Japan, as you know, Japan is one of the country that set right on the ring of fire. So they commonly have earthquakes and volcano eruption. So the structure of the earth is not stable. So whenever they build a huge building like this one, a tall building like this one, it will collapse easily, very easily. So what do? So for this, they have a backbone, just like I said there, and then everything around it has been attached to it. It's like a bamboo inside the pagoda, and then everything is attached onto it. So whenever the ground shakes, whenever the ground shake, now we have a different kind of force, which is a horizontal force. Shake, maybe a volcano eruption or earthquake. So everything will be tied onto this main pillar here, and then the pagoda won't collapse easily. It may have moved some millimeters because the pillar is actually flexible, but the pagoda won't be collapsed. So that's how incredible this architecture and engineering is. Okay, so I think that is all for the video today. Thank you for watching, and assalamualaikum.